All right, page 311 in your textbooks. Let's take a look at the homework that you did over the weekend. Number one, we were looking at, actually 1 through 10, we were looking at this stacked bar graph. And what is the chart title of this graph?
Coffee sales for Coffee Express.
Coffee sales for Coffee Express. So we assume that the business name is what, class?
Coffee
Express. We get that from the chart title. Now, there's two types of titles, right? The chart title's at the top of the chart of the graph, water bottle. And then we have axis titles as well. What are the two axis titles in this graph? Jalen?
Cups of coffee sold in location.
Good. So apparently Coffee Express actually has 4 different locations. And we're measuring the cups of coffee. But not only do we want to know which location sells the most coffee, but at each location, what types of coffees are being sold as well. And so we got 3 different kinds of coffee being sold. What are those 3 kinds of coffee, Elaine?
Iced, decaf, and regular.
There we go. So iced, which has all the extra frou-frou flavoring and creams and stuff added. And then decaf, which is, from what I understand from coffee, I don't drink coffee anyway, but from what I understand from coffee lovers, is having a form of coffee but denying the power thereof, as the scripture says. And then there's regular, which actually has all the drugs in it that are supposed to help you stay awake.
Oh.
Anyway, and so we take a look at our graph here. And question number 1, which location sold the most iced coffee? Not necessarily the most coffee, but the most iced coffee. Luciana?
The mall.
Yeah, the mall sold the most iced coffee. It's close between downtown and mall, but let's see. We're looking at 30 cups for the downtown location, and it's 35 cups at the mall location. So yes, the mall sold more iced coffee. Which location had the most overall coffee sales? Corey?
Downtown.
The downtown location. A lot of foot traffic going through there. People stopping to get coffee, bless you. So downtown had the most coffee. How many more cups of regular coffee did Main Street sell than Highway 98? So we're only concerned about 2 specific places. We're only concerned about the regular coffee, which is the dark brown. And how many more regular cups of coffee at Main Street than Highway 98? Bryson? 5 more. There we go, because Highway 98 sold, what is that, 25 cups of regular coffee. Main Street sold 30. How many total cups of regular and decaf coffee did Highway 98 sell? Griffin?
35.
35. So you're getting to Highway 98, you're going to go all the way up the bar until you get to the, I don't even know what that color is. It's kind of a, I don't know, tan, I guess. You go all the way up to the light tan color, and there's the 35. How many total cups of decaf coffee did the mall and Main Street sell? So you had to figure out decaf for the mall, decaf for Main Street, add those together. What did you get, Joel? 35 cups. Number 7, which location sold the most cups of regular coffee? Just looking at the graph here, Michael, I know you were out last time, but who had the most regular coffee sold?
Downtown.
Downtown. Their dark brown bar is higher than anyone else's. How many cups of iced coffee did Highway 98 sell? They didn't do a whole lot of business on the iced coffee, but Ben?
30.
Let's see, Highway 98 goes up to 50 total, right? And then the tan part starts about 35.
15.
There we go, 15 cups. There we go. Number 9, how many more cups of coffee did the mall sell than Main Street? How many more overall cups of coffee, they didn't specify which type, did the mall sell than Main Street? Kirsten? 15 more. Mall sold 80 cups of coffee. Main Street only sold 65. And then which location had the fewest cups of decaf coffee? People aren't buying decaf from this place. Jalen? Highway 98. Looks like they just had, 10 cups of decaf coffee that day. All right, questions. By the way, what kind of graph was that, class? Stacked bar graph, and allows us to see comparisons within groups while at the same time comparing the overall as well. Questions on the 1 through 10? How many perfect on the 1 through 10? You got all 10 answers right. How many got 8 or 9 right? You only missed 1 or 2 of these questions. All right, are there any questions on these? I didn't get that answer. I'm a little confused how you found it. Keeping in mind that we will be taking a quiz in just a few moments. Any questions on that? All right, turn the page. And let's take a look at our next graph. And Hawaiian tourists in 2016. What is that? The blurb thingy at the top. What do we call that, Elaine?
The title.
The chart title. There we go. And what kind of graph is Hawaiian tourists in 2016? Luciana?
Circle graph.
Circle graph. And they use colors on the graph, but they don't have a little color thingy off to the side. Like we did for the different shades of the brown that we use for the different coffee flavors or coffee types in the last one. What do we call that thing at the bottom of the coffee graph that tells us what each color means, class?
Legend.
The legend. We don't have a legend in this particular circle graph. They have instead the words right there, or the islands, I guess, right there on the graph itself. So we would call those labels then. And for each of these, they have the percents written out. What if they didn't have percents written out? How could we find a percent? How do you find a percent? Start by making a fraction. No, sorry. Start by making a fraction, and that'll give you your percent. What if they told us the percent and wanted us to find how many? Well, they'd also have to tell us a total, wouldn't they? And then we could simply multiply. Number 11, what percent of tourists visited Oahu Island in 2016? Corey? 50%. Half the tourists who went to Hawaii went to Oahu. What percent of tourists either visited Maui or Kauai? If that's how you pronounce it, I don't know. I've never been to Hawaii. Bryson?
35.
35%. We just add those two regions of the graph together. Which island obviously was visited the most, Griffin?
It's the one that starts with the O.
Oahu?
Yeah.
There we go, Oahu. Let's see. Which islands make up 38% of the visited islands? Which two islands make up 38% of the visited islands? Joel?
You skipped one.
Oh, well, answer number 15 anyway.
Big Island and Maui.
There we go, Big Island and Maui. Now let's go back to 14. Which islands were visited the least, Joel?
Lanai and Molokai.
Lanai and Molokai. That was good pronunciation, by the way. Which percent, number 16, of tourists visited Lanai or Molokai or the Big Island when they went and visited? What would you have here, Ben?
15%.
15%. Again, we add those together. What percent of tourists either visited Oahu or Kauai? Kirsten?
61.
61%. And then which two islands account for 74% of total tourists who visit the Hawaiian Islands, Ben?
Maui and Oahu.
There we go, Maui and Oahu. How many got all 8 of these correct? You went 8 for 8. Anyone just missed 1 or 2? Are there any questions on how to read the circle graph? All right, any questions on stacked bar graphs, or circle graphs? Did a lot of review in our last lesson. Any questions at all? All right, clear desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else off your desks. Everything else away. All right, this is quiz 31 for those watching on YouTube. Quiz 31. All right, when you get your quiz, put your first and last name in the name spot and today's date in the date spot. First and last name in the name spot, today's date in the date spot. And today is 4/22/24. First and last name, 4/22/24, today's date. 4/22/24. Let's take a look at the quiz together very quickly. Numbers 1 through 6. Just answer the questions. And then for 7 through 10, answer those questions about the graph. Show your work when you need to do a little bit of math. And there are just a couple places you'll have to do that. You may begin. Be sure to use the blank page as a cover sheet. Use your blank paper as a cover sheet. Number 5, there's a few different ways you can answer that, and I will accept any correct answers on 5. So just put what you remember. There's not one specific word, there's a few different answers I will take. Access to the video too. I mean, it's not like you couldn't. Sure, you're using your cover sheets. Do your best. Just a couple more minutes, do you think? See some exposed papers. Just about 30 seconds longer to finish it. All right, go ahead and pass those forward, if you would, please. Pass those forward, if you would, please. We'll take a look at those in our next lesson together. And take your textbooks. You can open back up to page 312. Open back up to page 312. Page 312, and we're going to be skipping over some things, but I just want to point things out to you. You won't be tested or quizzed on this year, but just something that you can see next year in pre-algebra, something to look forward to. And of course, you're welcome, of course, to look this over if you wanted to. You're bored in study hall, got nothing better to do. I wonder what we're skipping. So we got something called a box and whisker plot, which is another way to summarize a data set. We talked about the mean. Well, that's the average. We talked about the median. We talked about mode. Well, the median is something that actually appears on a box and whisker plot. The highest number, the lowest number, then some medians of halves and cool stuff like that. So you see all of that with the box and whisker plots. Flip the pages over a little bit. Keep flipping pages. Keep flipping pages till you get to page 320. And we see stem and leaf plots. And basically a stem and leaf plot is an annoying way to actually list out every single data set, every single data value in a set. So for instance, if you had the numbers 32, 35, and 37, they would write the 3 once and the 2, 5, and 7 after that. You see that there on page 320. So if you were to see that second little blue shaded box here, well, the actual numbers in the data set are 5, 7, 9, 15, 22, 45, 50, and 56. Do you kind of see what they did with the stems and leaves? Again, not going to be tested or quizzed on that, but we can skip over that, flip a few more pages, keep flipping pages till we get to page 327. And this is something we're going to go over this year. So again, anything with box and whisker plot, stem and leaf plot, we're not going to worry about those this year. We'll talk more about those in 8th grade pre-algebra. We do want to talk about a histogram. If you look at the histogram, you're like, wait a second. This thing looks like a bar graph, doesn't it? But here's what we do with the histogram. Okay, if you write this down, histogram is used to compare groups to each other. A histogram is used to compare groups to each other, where data is broken into groupings rather than individual values. For instance, we know that throughout the history of the United States, different states have entered the Union in different years. It isn't like you have to wait for a specific year to join the United States of America, or states did not have to along the way, but it just so happened that between 1770 and 1790, 12 states joined the Union. There was a 13th holdout that eventually joined shortly after 1790. 1790 to 1810 reflects a range of years, and any states that joined the Union in that range of years goes into that next group. Anything that joined between 1810 and 1830 goes into that next range of values. Does that make sense? Rather than comparing individual years to each other, a group of years. Does that make sense? Kind of like when we look at your grades. Okay, rather than list how many hundreds, how many 99s, how many 98s, good grief, right? But how many A's? How many B's? How many C's? How many F's? And so we break it into groups, right? Rather than each individual grade, we don't care about each grade necessarily as far as, the overall analysis, just how many people in each grade range. Does that make sense? If we were comparing in the school, we might decide, okay, how about kindergarten and pre-K, lower elementary, upper elementary, junior high, high school. We could group you into those divisions as well. Well, anytime you use a bar graph, essentially, that compares groups to each other, that's a histogram. It shows you see this word, their frequency. How frequently does something happen within a group? So frequency within groups, that's the purpose of a histogram. Now, one of the obvious differences between the bar graphs we were looking at and this bar graph, what do you notice about the bars? Just call it out.
The bars are
They're touching each other. There are no distinct gaps between these, right? Because, think about it, 1770 to 1790, where that time period ends, the next one begins, right? Is there a clear break between A's and B's? No. 90 is the difference, right? Like once you hit 90, you're into the A range. Until you hit 90, you're in the B range. But there's not really a gap between those. Does that make sense? So because there aren't necessarily gaps between groups, we'll break that down as well. If we wanted to show, for instance, average incomes in the U.S. or something like that, and we said, well, how about the people who make from $0 up to $40,000? And then the people who make from $40,000 up to $80,000. Well, is there a gap between those two? No, so then when we draw the bars, the one bar and the next bar are going to be touching because there's not actually a gap between those two groups. Does that make sense? So that's one of the keys to the histogram is you can't have gaps in the groupings. The groupings just go from one flow right into the next. That's where the histogram is a little bit different. Now here's something we need to make note of. What if you make exactly $40,000? Which bar do you fit into? You always push up to the next bar. So if you're on the dividing line, so at the divide, you go up to next group. If you'll jot that in your notes. If you're at the divide, you go up to the next group. So, as we look at when states enter the Union, if a state joined the Union in 1790, which class would it go into? The 1790 to 1810. Does that make sense? 1790 to 1810. So each bar represents a grouping here. Now the way we would label the bars, so we wouldn't label them 0 to 40,000, 40,000, 80,000. It would be written this way. You make no money, you make 40K, you make 80K. And then it would just continue on, but for sake of illustration, we just show that. Right? Anybody who makes an annual income between $0 and $40,000 is going in this bar. Does that make sense? But technically, $39,999.99. Because once you get to the 40,000, now you're in this bar. Anyone from 40,000 to $79,999.99 goes in that bar. Does that make sense? We understand that, okay? So that's how the bars work. So, in which grouping of years did the most states join the Union, class?
1770 to 1790.
Good. And a lot of those would have joined when the Constitution was established and ratified by the states in the late 1780s, if I'm not mistaken, which really is when the United States was formed, right? They have won independence, well, declared independence in 1776, well, won it in 1783, I think, but didn't officially establish anything until the later 1780s. But all those states are kind of in that first thing. The no states joined in what group of years, class?
1970 to 1950.
And none of them have joined since 1970 either, though there's a push to get Puerto Rico to join as a state. Not sure why. Well, actually, I do kind of know why, but we're not going to go into politics. But you notice that later years, 1910 to 1930, only 1910 and 1930, how many states?
Two.
Just two new states. And then 1950 to 1970, again, two new states. Which two joined between 1950 and 1970?
Alaska.
Hawaii and Alaska joined 1950 to 1970. So it did turn nifty-50 until the last two joined. And then it was, I don't know what they called it when there were only 48 of them. But anyway. Questions on that? Flip the page. Let's take a look at a couple more histograms here on page 328. Rather than asking, okay, how many adults are this age, this age, this age, this just broke the adults in the neighborhood down to groupings. And the first group of adults that's listed there are adults classed between the ages of 20 and 30. How many adults are 20 to 30 years old?
21.
22. It goes up 2 lines, 2 minor grid lines. Then, now, if an adult is actually 30, will they be in that first bar? No. So if they have their 30th birthday when we take the poll, if they're exactly 30, they're not in that first bar. They're now moving into the 30 to 40 bar. How many 30 to 40-year-old adults in the neighborhood? 27. Okay, how many 40 to 50-year-old adults? 19. And 50 to 60? How many 90 to 100-year-olds? 0, 90 to 100, which tells us that all the adults must be younger than 90 years old. They're all in their 80s still, because again, if you turned 90, you technically go into the next bar. There's no bar there. Now, if you were to write it down, do you see what they did at the bottom of, like under the 1 through 4? They went ahead and wrote out all the numbers. 22 20-year-olds, 27 30-year-olds, 19 40-year-olds, all that. You could even get the total if you really wanted to, couldn't you? They added them all together. They found there were 112 total adults. Now look at the questions they answered. How many adults between 50 and 60? We already said class 20. Goes right up to the 20. How many people older than 80?
2.
Only 2. Does the histogram tell us how many adults are exactly 45 years old? No. We know there are 19 people in their 40s, so I mean there could be 19 people 45 years old. It's unlikely, but there could be that many. We don't know how many are exactly 45. The purpose of the histogram isn't to give us exact data. It's to break people down into groupings and show the frequency there. Look at number 4. What percent of adults? Wait, how do we find percent? No, that's percent of change. Just in general, find any percent. Make a fraction. So that's what they did. Do you see that? They made a fraction. They said, well, there's 27 30 to 40-year-olds. There's 112 total people. They went and found that math. They divided it out, got 0.24 approximately, so 24%. Questions on the first histogram? All right, look at the bottom histogram here. And read the problem in bold, if you would, please, Corey.
Carly is researching the ages of children in her neighborhood. She finds the children fall into the following classes. Construct a histogram of the children in Carly's neighborhood.
All right, so they made a histogram based on the numbers. So she started with a frequency table. Do you see that? Kind of tying everything together. That was last chapter, but it all connects. So babies, 0 to 3 years old, there were 5 of them in her neighborhood. 3 to 6-year-olds, 7, 6 to 9-year-olds, 4, 9 to 12-year-olds, 11, 12 to 15-year-olds, 9, 15 to 18-year-olds, 3. Well, remember, just like a bar graph or a line graph, a histogram is kind of like a bar graph. It can't hit the top. Her biggest group of kids class has how many kids in it? 11, right? The 9 to 12-year-olds is 11. Her graph better go higher than 11. Does that make sense? And it did. She went to 12. Doesn't have to go much higher, just has to go higher. So she took her graph up to 12. Well, what would be a good way to break down grid lines if you're going from 0 to 12?
1.
Well, you could do well, I was going to say major grid lines, I'm sorry, but major grid lines, you could label every 1. I'd rather not. She went and labeled every 2. But she still provided grid lines, minor grid lines for every 1. Now, notice the way she broke them down. Notice there are even groups of ages. 0 to 3, 3 to 6, 6 to 9, 9 to 12. Do you see that? So that's important. That way her bars can all be of nice equal width. Notice she only wanted kids, right? So technically, once a person turns 18, are they still a kid? No, they're an adult. They're punishable to the full extent of the law. Anyway, so she only needs to show 0 to 18, right? So if you were drawing your own graph, starting from 0, and then you get 18, you need to break it down into these nice even categories. So maybe she said, well, I'm going to go halfway to 9. I'm going to try to break that into even thirds and call this 3, 6, break this down into even thirds, 12, 15. And then just try to make the bars of equal width best you can. Now, it's computer generated, okay? It's going to be perfect. If you make a histogram, it might not be exactly perfect, but we can make it close. Now again, once a kid turns 3, which bar do they go into, class?
36.
The 3 to 6 bar. Once a kid turns 12, they go into which bar? 12 to 15. What if the kid's 11?
9
The 9 to 12 bar, right? And just draw the bars of the appropriate heights. They're all touching each other. She made an axis titles of age and children, I guess needed there. And then there are her chart title, neighborhood children. And we see all of that. Questions on the histogram. Again, it's like a bar graph, just shows groupings. Look across the page. What's the chart title for our purple histogram here, Bryson? History test score. So we're going to see how the kids in the history class did. Now, there is a vertical scale, and pretty obvious. What does the vertical scale, number 2, represent? We already answered number 1. Number 2, what does the vertical scale represent? Michael?
students.
The number of students who scored in each range of grades. Okay, so students. And the horizontal scale obviously represents what, Joel?
Scale.
The horizontal scale represents what? Number 3. You have to look at the graph. What does the horizontal scale represent? Do you see, look at the purple graph. Okay, do you see the horizontal scale? Do you know what horizontal means? Side. Okay, that's the problem. We don't know what horizontal means. Horizontal means side to side. So look across the bottom. Do you see how there's a side to side horizontal scale? What do those numbers mean?
The age groups.
Horizontally? What does it say right under the numbers?
Oh, the axis title.
Yeah, what does the axis title say?
Scores.
Scores! So that's what those numbers mean. It means their scores. These are their grades that they made on their history tests. Right, so that's why the axis title is there, so we don't have to wonder what it means. Now, that would be a real problem if the history students were between the ages of 40 and 50, 50 and 60, 60 to 70, 70 to... That would be really rotten ages for a history class. No fun to teach old people. They don't learn too well. You just can't teach an old dog new tricks, as they say. No, let's talk about scores, and that's why there's axis titles to help us understand these things. Now, how many students scored below 50 on this history test? Elaine? One poor soul was not prepared for the history test and scored below a 50. How many students scored between a 60 and a 70 on this history test? By Georgia standards, they failed. It was a high F, but they failed. By a lot of other states' standards, they made a D, which is still really sad. But how many students scored between 60 and 70, Kirsten?
5.
5. Now, would any of those students actually have scored a 70, Kirsten? No, because if they scored a 70, they would have been in the next category. How many students scored 80 or better on the test? How many students scored 80 or better, Jalen? 7. Now you say, wait a second, 80 to 90 only goes up to 5. Yeah, but 90 to 100 is also better than 80, isn't it? And so she factored in those two as well. 7 students scored an 80 or better on this history test. Who scored 90 or better, meaning they made an A on this history test? Ben?
2.
Just 2 A's on the history test, so not a real strong showing. What grade range did most of the students score in? What was the most common grade that students would have scored? Luciana?
70 to 80.
Somewhere in the 70 to 80 range. So by just about any state standards, a C. Most of the students got a C, which C means average, so it makes sense that most of the students would have scored in that range. Number 8, how many students does the histogram represent? You're going to have to do some quick math. How many students does the histogram represent? A few students were calculating a little early. They've already got it. Corey, how many total kids apparently in this class?
23.
23 test scores represented. We presume that means 23 students in the class. Does the histogram show exactly what each student made on the test, Griffin?
No.
No. It just shows, what ranges they scored. So if his kid scored a 74, another kid scored a 77, we wouldn't know the difference. They're just both in the 70 to 80 range. What percent of the students scored below a 60? What percent of the students scored below a 60? Well, first of all, we got to figure out how many students scored below a 60, Joel. 4 students out of how many total again, class?
23.
23. We found that in number 8. So if 4 out of 23, class, start by making a fraction and then do what to find your percent? Divide. What number goes in the house?
4.
The 4. The top number goes in the house. Put the 23 outside. Divide it out. And what do we get for the students who struggled badly on the history test? Just make sure this is never you on the history test. Scoring below 60. Sounds sad. How many, Jalen?
17%.
About 17% when you divide it out. About 17%. Doesn't come out evenly, but it's set around in the nearest whole percent. Michael, question?
What would happen if someone made 100 on the test?
Well, since there's not a separate bar for that, obviously in that case the hundreds would get lumped into the 90 to 100 bar because there's not another bar to go into. Yeah, good question. For instance, Michael, if we were, I erased it now, but if we went back to our analogy of how much money people make, and we said, okay, we're going to have you make no money, 0,000, and then 40,000,
Okay.
and then 80,000, and then 120,000, and then 160,000, and then 200,000. Well, honestly, once you get past about 160,000 or 200,000, there are so few people in America making that number. I might do up to, I don't know, 240K plus, and just anybody up to this range, or anything above 200,000 just goes in that bar. And so your millionaires, your billionaires, there's not that many of them, so just put them all in one bar together. But yeah, that's what you'd have to do here. If you actually made 100, there's not a separate bar for you, so you get to, at that point, since you're in the final bar, you don't have to bump up to the next one, because there is no next one. Good question. Good thought there, too. Questions on that? All right, let's look at constructing a histogram here. So we're going to actually make one of these here. Read number 11 for us first, though, if you would, Ben.
A group of students were asked to estimate the number of pages in a certain book. Below is a table showing the results.
I'll be honest, I am not really sure what it's talking about here, unless some English teacher's all right, students, how many pages, by the way, do y'all have to have in your book report books? 200 or more?
Like 250.
50 to 200. Yeah, 150.
150 to 200? Y'all don't even know what your book report, this is sad, I'm going to tell them this is hard. Anyway, let's just suppose, let's just throw out an ambiguous number, let's just suppose we say 150 pages, okay, is how many is supposed to be in your book report books. And so Mrs. Albrecht is trying to make a point, and she says, okay, folks, look at this book, and she holds up a skinny little book. Folks, do we think this book has enough pages? Yeah. Do we really need to even open it up and see? Or can we just kind of tell it's not enough pages? How many pages do you think are in this book? And she goes around the room asking you how many pages you think are in the book. And rather than writing down every student's response, we're breaking down the pages this way. How many students guessed that the book, I think this is what they're having us do. How many students guessed that the book that was held up had between 75 and 84 pages? Class?
4 students.
4 students. Now, it says 75 to 84 because you can't have a partial page. You could have partial printing on a page, but you're not let's be real, okay? All you're doing is looking at the end to see how many total pages it says there are, right? If there's a picture on the page, you're not subtracting that, are you? And you're not it says 203 pages, but there were 17 pages that only had partial printing. So it's not really 203, so I need to find a longer book. Or there was a picture taking up half of one page. I need to, y'all ain't doing that. You're just no. It says 202, including the index, glossary, advertisements. It's 200 pages. And then Mrs. Aubrey can be yeah, no, the book actually stops on this page, you notice? Anyway, I was 7th grade once, okay? I remember these things. But anyway, so we're not worried about partial pages, so we don't have to worry about 84 and a half, okay? The 85th page goes into the next category. 85 to 94, class, there were 7 students, 95 to 104. 8, 105 to 114.
3.
And the highest guess in the class was somewhere between 115 and 125, and there was only one person who guessed that. Okay, so when you make your chart, do you see how they've already set up your chart title? What is the chart title they have given you? Elaine?
Estimated pages in a book.
All right, they've already given you your scale going up the side vertically. Vertically going up the side. Vertically, up the side, okay? And so notice their highest number vertically, class, is 10. Because the highest number they actually need to show is 8. And let's be real. Do we really want to do 9? 9 is such an awkward number. Like, unless you're going to divide major grid lines by 3, that's kind of a random number. So they're like, you know what, 10's a nice, easy number. We'll stop at 10. That way it doesn't hit the top. We don't hit the top, okay? I think I've pounded that in now. Because you're going to be doing one of these later. So don't hit the top, and they don't hit the top. They've also got nice, evenly broken down little thing across the bottom. They got their axis titles and everything. And so all we got to do is finish the bars. So they even have little notches down here to help you just a little bit. So all you got to do is come off the little notches, and it's nice and even. All right, so they got their 10, and their 8, and their 6, and their 4, and their 2, and of course 0. And they've got their minor grid lines real lightly in here. All right. All right, so your first bar needs to go up to what point, class? 4. So let me show you the best way to do this. Find this little mark. And you can either go up or you can guesstimate the width and go straight down. Just draw the line straight down. Highlight on top of it. And when I shade in, I don't shade in like this. Just,
I split lines. 1, 2, 3.
there we go. All right, then for the next bar, class, it needs to go up to 7. Okay, so extend this bar up to the 7 or come down to it from the 7. Find this bar, find that same width, go straight down from the 7, highlight across the top, scribble in. If you have not already done so. Some of y'all need to wait for me next time to follow along. The next one goes up to 8. So we just go up one more bar, come down to the 105, highlight across the top, and scribble down the side. The next bar only goes up to 3. So we're going to come down from the 3, highlight across the top, scribble in bar. And the last one, of course, just 1. So highlight, go down, scribble in, and boom, we have histogram. Seem pretty easy to make histogram. All right, let me come around and take a look at histograms real quick, make sure they look good. Make sure you highlight across the top and don't scribble above it. So I would not, notice by the way, when I scribbled in, I didn't go vertically where I might accidentally go above the top of the bar. I scribbled side to side and I made sure I didn't actually hit the edges. It shades in without accidentally bleeding over. So that would be my tip on that, just to make sure things look nice and neat. Again, don't bleed above the tops of the bars. Maybe a little bit neater, okay, following the guidelines I was giving there. You do the slashy end zone style lines. That works. I like the purple highlighter. Try to keep those widths consistent. Notice how this line kind of started drifting, but try to keep them nice and neat and sharp. Good. Ish. Maybe a little bit more like I was showing. All right, go into the next one. Go to the next one. Make sure we're nice and crisp straight lines. So see how this is kind of squiggled? It'll be nice and crisp and straight across the tops. Well, no, because you weren't taking time to. So take some time to sharpen it up. Put a little effort in. All we do to the glory of God. Even making a histogram can be done in a way that glorifies God by when we put forth good effort. So I want to make sure we make things look nice and neat. Because you're not really doing it for me. You're doing it for God as you're learning. The whole point of education is to learn so you can be prepared to do whatever God wants you to do one day. Have you ever wondered, by the way, when the Bible says whether you eat or drink, do all to the glory of God, you're like, how can you eat or drink? Like, doesn't that seem silly? I think the point is, no matter what you're doing, even if it's eating or drinking, you can do it in a way that pleases God. So certainly making histograms. Well, choosing what you eat and drink obviously would make a difference, right? But also, I don't know, the amount you eat or drink could certainly make a difference. Eating like a slob wouldn't bring glory to God. So, that we can eat in a manner that is pleasant and that is, polite. So, yeah. But everything we do, we want to make sure we're doing for Him. So, nice, neat histogram. See if the second one can look a little sharper even than the first. Also, make sure you fill in your chart title at the top of the second histogram. Get your chart title, get your axis titles. Get your chart title on there, get your axis titles on there. So we need a chart title filled in, we need axis titles filled in. You get the axis titles on there. Remember that last bar is actually just going to run right down the side edge.
I should stop one of the examples to do it.
Say what?
Since it's like basically doing the same thing, the grades, I just use what they did up there and just change to English.
There we go. Yeah, so he's saying, hey, we could kind of mimic what they had on the purple histogram up above it. Just, doctored a little bit. And the people with Sharpie markers and highlighters are enjoying having an opportunity to add a pop of color to their books. What? Yeah, okay, it might be being extra. Others of you are leaving the highlighters in their bundles and not employing them at all, and that's okay too. You can just use a pencil, that's fine. Now, when you do one of these tonight for homework, you are going to be having to do it on paper. Okay, you're going to end up doing it on paper. So you're going to have to make it yourself, kind of like what you saw me do on the chalkboard, though at least the notebook paper has some lines. Now, those of you who happen to have graph paper, you could use graph paper to help you shape those lines a little bit neater because you have the squares going both ways. So it wouldn't be a bad idea to do this on graph paper. Your homework for this evening is to do page 330. Page 330, the review. We're jumping around a little bit here, so make sure you write this down carefully. And when you do the homework, make sure you look through your assignment pad. Make sure you're doing exactly what you have written down. Page 330, the review, 13 through 16. So just a few little problems there. And then drop all the way down to 25 to 27. 13 through 16, 25 to 27. Then on pages 330 to 331. Page 330 to 331. We're going to do the same kind of jump around as we did on the review section in the homework section. Page 330 to 331. Homework 1 through 6 and 15 to 17. Page 330 to 331. The homework 1 through 6 and 15 to 17. So we're doing a 13 through, stay with me, double check, make sure you got it written down correctly. We've got a 13 through 16, and then a 25 to 27. Then we got a 1 through 6, and a 15 to 17. So skipping over some sections there because we skipped over the stem and leaf plots and the box and whisker plots. All right, you are dismissed. Have a wonderful rest of your day.
Now I'm having